We're going to do lessons 3.6 and 3.7 today. 3.6 is about zeros of a quadratic function, and 3.7 is about families of quadratic functions. Um, so you have a quadratic that could have any one of these three scenarios. If it crosses the x-axis at 2 points, that means there are two zeros or two solutions or two x-intercepts. If it only touches the x-axis at 1 point, which is at the vertex, that means it has only one zero or one solution or one x-intercept. And there's also scenarios where it never touches the x-axis, like in this case here, you have there's no solution, no zero. So you can have three scenarios that happen with a quadratic function. It can have two x-intercepts or one intercepts or zero x-intercepts. There are three methods to determine the number of zeros of a quadratic equation. One is to use the vertex and direction of opening. So for example, if you have a parabola that has a vertex 3, 4, it opens up. A rough sketch would be like this. You know, it opens up. It's never going to touch the x-axis. So in this case, there are no zeros, no roots. Okay? And if it's a parabola that's 3, 4 and opens down, then you know that it's going to have two zeros because it's going to touch the x-axis at 2 points. Another method is if you are given it in the factored form, then you can, like in this case, it's touching the x-intercepts are 3, 0 and 4, 0. So you know there's two zeros in this case, right? There's two solutions or two solutions. And this case, this is also in factored form. There's only one root. The x-intercept here in this case is 1, 0. There's only one root or 1, 0 or one solution in this case. And if it's given to you in the standard form, then you can use what's called the discriminant. Use the discriminant. The discriminant is b squared minus 4ac, which you see in the quadratic formula. So if you do b squared minus 4ac, you could get three scenarios. You could get a value that's greater than 0, or you could get b squared minus 4ac equal to 0, or you could get a discriminant value b squared minus 4ac less than 0. So there's three possibilities. If it's a value that's greater than 0, that means there's two roots or two solutions. If it's equal to 0, there is only one root or one solution. And if it's less than 0, that means there is no roots or no x-intercepts or no solution. So that's the way you would go about finding the number of zeros in a quadratic equation. So let's try an example here. You've given this, you have to find the number of zeros. You don't have to solve it. So it's in the standard form. I'm just going to go ahead and find the discriminant, b squared minus 4ac. So that's, in this case, 16 minus 16, which is equal to 0. So therefore, one root, because the discriminant is equal to 0. Negative 5x squared plus 6x minus 2. B squared minus 4ac, b squared is 1, so it's 1 minus 40, which is negative 39. Negative 39 is a value less than 0, so there is no roots or no solutions. And this one here, again in standard form, let's find the discriminant. B squared minus 4ac equals 9 plus 10, 40, 9 plus 40. So you get 49, which is greater than 0. So therefore, there's two roots or two solutions. Example 2, we have to determine the value of k so that the function f of x equals kx squared minus 2x plus 3 has 1, 0 in part A, or 2 zeros in part B, and C, no zeros. So we're going to, if it's only one, there's only one 0, that means b squared minus 4ac equals to 0, which means negative 2 squared minus 4 times a, which in this case is k, times 3 equals 0. So 4 minus 12k equals 0. Negative 12k equals negative 4. Divide both sides by negative 12, and you get k equals 1/3. So that's the value of k for which you get 1, 0 in part A. And then for part B, you should have 2 roots. So that means b squared minus 4ac should be greater than 0, which means 4 minus 12k, which is b squared minus 4ac, should be greater than 0, which means negative 12k should be greater than negative 4. And you divide both sides by negative 12, which means k should be less than 1/3. So any value of k less than 1/3 will satisfy this. And when there are no zeros, that means b squared minus 4ac, the discriminant should be less than 0, which means 4 minus 12k is less than 0, or negative 12k is less than negative 4. Divide both sides by negative 12, and you get k should be a value greater than 1/3. So any value of k which is greater than 1/3 will satisfy that there will be no roots. A word problem. The profit function for a particular new business is p of x equals negative 0.3x squared plus 3x minus 15, where x is based on the number of items produced. Will it be possible for the business to break even? Well, to break even, that means the profit is equal to 0. So the profit function is equal to 0. So in this equation, you're going to put p of x equals 0. You get 0 equals negative 0.3x squared plus 3x minus 15. And when you solve this equation, you would get the value of x for which p of x is equal to 0. So in order to just, we don't need to solve it because it's not asking us to find what the number of items are. It just says, is it possible to break even? Well, we can just do the discriminant part, b squared minus 4ac, and answer that question, which is 9 minus 4 times negative 0.3 times negative 15, which is equal to 9 minus 18, which is equal to negative 9, which is a value less than 0. So there's no roots, which means it's not possible, right? Because if the profit function is not 0, so therefore it is not possible to break even. Okay. 3.7 is about families of quadratic functions. So you notice here I have 3 quadratics. They all pass through the same x-intercept. So they all have the same roots or same values of roots. But if you look at the functions I've plotted here, you have x squared minus 3x minus 10, 2x, negative 2x squared plus 6x plus 20. And what you notice is each of these is actually like equivalent to the other. So if you take the first one and you multiply it by negative 2, you get the second equation or second function. If you multiply the first equation or first function by 4, you get a 3x. And if you multiply the first function by negative 0.5, you get this. So these are all kind of equivalent quadratic functions. Right? So what happens is equivalent quadratic functions where the a, b, and c are just factors of each other will result in a quadratic that has different shape, right? It has different shape. It can also open up or down depending on the a value, but it'll have the same zeros or the same roots. Okay, they always pass the same x-intercepts. Another family of quadratic functions is one I have here where they have the same vertex. So if you look at the functions, they all look the same. And what you notice is they have the same vertex. So that's a family of quadratic equations that have the same vertex. So if you converted them into the vertex form, you would find that the vertex would work out to be 1, 3 in each of these cases. Okay. The third family I have here is quadratics, that the functions f1, f2, f3, and f4. And what do you notice about these 4? Well, these 4, they have They have different zeros, so they have different roots, so they have different zeros. They have the same y-intercept though. They all pass through this point. Same y-intercept. They have different vertices, or vertexes, it's plural vertices. And they have different stretch factors, right? Different stretches or compressions. So they're all different except for this one point, which is they have the same y-intercept, which is right here. They all pass through this point on the y-axis, which is 0, comma, -2. They all have that same y-intercept. And you can also see it from the equation in standard form. The c value is -2. So you can tell when it's in standard form, you can tell what the y-intercept is because that is the c value, which is in this case -2. So the y-intercept is -2, comma, 0. So quadratics belong to the same family if they have the same vertex like we saw in the first example, or if they have the same x-intercepts as we saw in the second example, or if they have the same y-intercept as we saw in the third example. And you can tell them at a glance by just looking at their vertex. If they're not given in vertex form and you convert them to vertex form, you can see that. If they're in factored form, you can see that they have the same x-intercepts. And if they are in the standard form, you can see that they have the same y-intercept. So find an equation of a quadratic with a vertex -3, comma, 5, and that passes through -6, comma, 4. So what would that, it says find an equation, right? So because it's passing through -6, -4, we're going to say, well, one equation could be, because you could have several, because they could be all in a family that have the same vertex, right? But find an equation of a quadratic that passes through this vertex, but it also has a particular point. So that kind of fixes where it is. So equation could be, not one equation, the equation could be y equals, in the vertex form, ax minus h squared plus k. H and k are given here in the vertex, so y equals ax minus -3, which is x plus 3 squared plus 5. Now, you need to find the value of a to come up with the entire equation. So to find a, you can substitute this point here. You're going to substitute -6, -4, which is a point on the parabola. So you substitute -6, -4. So you get -4 equals a -6 plus 3 squared plus 5. And that works out to -4 equals -3 squared, which is 9a plus 5. Or 9a equals -9, and a equals -1. So then you have, therefore, the equation of the parabola is y equals -x plus 3 squared plus 5. So that's the equation of the parabola that has -3, 5 as its vertex, and it passes through that point -6, -4. Okay. We have another example here. Find the equation of a quadratic that passes through 5, -1 and passes through a point 2, -3. So same idea, but this case they're giving you the zeros. There are two x-intercepts. So you're going to go with the factored form because they're giving you the x-intercepts. So you're going to say y equals a x minus 5, x minus -1, which is x plus 1. And then you're going to substitute the point in the parabola, which is 2, -3. So -3 equals a, 2 minus 5, 2 plus 1. -3 is equal to a, -3, 3. -9a equals -3. Divide both sides by -9, and you get a equals 1/3. So therefore, the equation of this quadratic is y equals 1/3 x minus 5 x plus 1. It's in factored form. Now you have a word problem where you have a parabolic bridge that is to be built over a 2-lane highway 12 meters wide to allow 2 trucks 4 meters wide and 5.5 meters tall to pass with at least 1 meters between them. Find the equation that models the situation. And the scale is that 1 meters is equal to 1 centimeters if you were trying to draw it to scale. So here you have two trucks. Let's just break down all the information given to us. They are 4 meters wide each. So there's about 4 meters here between this. And then there's at least 1 meters between them. So let's just take it as 1 meters here between them. So that's the highway. And the entire width of this is 12 meters. So it says highway 12 meters wide. So it's 12 meters wide for the entire highway. And the the height of the truck is 5.5 meters. So that's all the given information. And you have to build a bridge over it. So you're going to think of a parabola that goes, let's say, let's just make it different. Try to draw. Let's work with this parabola. Like it's going something like this. Like I'm thinking maybe I'll draw it freehand. So let's draw it freehand. Let's say it's let's say it goes like that. Okay, so that's a parabola. Then that would be the bridge. Then how would we come up with some points that would help us solve this problem? Okay, that would help us come up with the equation of this quadratic, which is the bridge. So we can now look at points that we have here. Like if we were to place the x and y axis, let's say this is the y-axis. Let's say this is the y-axis, and this is the x-axis. So you have the x-axis and the y-axis. That would make this point like your origin, 0, 0, and that would make this point, because it's 12 meters from the start, it's 12, 0. So that gives us 2 points in the parabola. And then a third point we need, because if we were to go with the factored form, we would need a third point to substitute. So that would be this point here maybe, because if the whole thing is 12 meters, so there's 4 plus 4 is 8 plus 1, 9, that means this distance here is 1.5 meters, and this distance here is also 1.5 meters. So that would make this point 1.5, 5.5. So now you have 3 points, these 3 points, and you can then use that to come up with the equation of the parabola. So here it is. I have the diagram here drawn. So you have, these are the two x-intercepts. This is a point in the parabola, 5.5, 1.5. So that's a point on the parabola or the bridge, the parabolic bridge, and we're going to use those points to come up with the factored form. So I wrote the factored form here: y equals ax minus 0x minus 12, and I substituted 1.5, 5.5. And I got the a value as negative of 5.5 divided by 15.75, which I just brought it to lowest terms as 22 over 63. And then that is the equation of the bridge. Okay, so that's the equation of the parabola, or the parabolic bridge.